Okay, so our last lesson on matrices, 4-7, solving linear systems using inverse and Cramer's rule. And again, like the last lesson, this is going to repeat some of the information we learned last week from the Algebra 2 book and then add in the new pre-calc level work. So we're going to be able to solve systems of linear equations using inverse matrices and solve using Cramer's rule. So the square system, a system of linear equations that has the same number of equations as variables, the coefficient matrix is a square. And if the matrix is invertible, then it has a solution. So let's look at example 1. What we're going to do is we're going to make the matrix. And we're going to just use the coefficients. So 2, -1, 2, and 3. And then we're going to say times, and the variables are x and y. And then equals, and we're going to equal our answers, which are 1 and 13. So we have our coefficients of the variables, our variables, and then our answer. Okay, so the first thing we're going to do is inverse this matrix. And if you remember inversing, we can do 1 over the determinant. So let's find our determinant. 2 times 3 is 6. Minus 2 times -1 is -2. So our determinant's 8. So 1 over 8. And then remember to do inverse, or to do the inverse, we're going to switch these two. Right? So 3 and 2. And then we're going to change the signs on these ones. So 1 becomes positive and 2 becomes negative. Okay, so that's the rule we learned. And then we're going to distribute this. 1/8. So we get 3/8. 1/8, -1/4, and +1/4. So once we inverse this, remember inverse is like the reciprocal. So if we inverse it and we multiply by the answer, it will give us the xy values. So we're going to multiply this by 113. And if you remember how to multiply a matrix, we do our rows by our column, okay, and we create. So this is a 2 by 2 matrix, and this is a 2 by 1, so our answer will be a 2 by 1. So let's get this matrix solved. So if I take the 3/8 and multiply by 1, I have 3/8, and I'm going to add it to the product of 1/8 and 13, or 13/8. Then on the bottom row, we've got 1/4 times times 1, so -1/4, added to 1/4 times 13 is 13/4. And if we solve those, 3/8 plus 13/8 is 16 over 8, which is equivalent to 2. -1/4 plus 13/4 is 12/4, which is equivalent to 3. So our answer, x is 2 and y is 3. Or you can write that as a coordinate 2, 3. Sorry about that going off the page. I'll leave it for a second in case you're catching up. Okay, so you're going to take the matrix set up with just the coefficients times the variables equals the answer. You're going to inverse this matrix and then multiply it by the answer, and you'll get the values for x and y. Okay, so if you turn the page, we're going to have a system of 3 now. So 3 equations with 3 variables. So let's start off doing the same process. Our coefficients are 2, 1, and 0. 1, -3, and 2. And then there's no x here, so 0, 5, and -3. And then that's going to be times x, y, and z. And the answer is 9, 12, -11. Okay, so again, this is the coefficients for x, y, and z on each of these. And then x, y, and z, and then the answer. So first thing we have to do is inverse this. What I'm going to tell you is I found the inverse already, because we would normally use a graphing calculator to inverse this, but you don't have that ability. So you're not going to do any systems of 3 on your own. I'm just going to show you how this works. So if we inverse this, the inverse would be -1, 3, 2, 3, -6, -4, 5, -10, -7. So that is the inverse if you use a calculator to find that. Okay, so again, without a graphing calculator, we are taking some shortcut steps. Otherwise, I can teach you how to do this on a calculator. So that's that, times, and then again, we multiply it by the answer, equals the XYZ. So now we're going to multiply these. So again, it's row by column. So here's our column. We have 3 rows. The matrix, this one is a 3 by 3 and a 3 by 1. So our answer should be a 3 by 1. So let's figure this out. So -1 times 9 is -9, plus 3 times 12 is 36, plus 2 times -11 is -22. Then we go to so that's the first row. Second row, 3 times 9 is 27, plus -6 times 12 is -72, plus -4 times -11 is +44. And then we have the last row. 5 times 9 is 45. -10 times 12 is -120. And -7 times -11 is 77. And if we simplify those, the top row is 5. The next one is -1. And the last one is 2. So our answers are x equals 5, y equals -1, and z equals 2. And we've now solved our matrix, our system of equations. So again, to solve a system of equations using inverse matrices, we're going to take the inverse, multiply it by the answer, and it's going to give us our variables. We can only do this with 2's, or if we had a graphing calculator, we could do this with 3's. We're not going to learn how to inverse a 3 by 3. Okay, so now we're going to talk about Cramer's rule. And this is a review. We did Cramer's rule last week. So a review of Cramer's rule if we have 2 variables. Okay, so the first thing to do for Cramer's rule is to find the denominator. It's going to be the same on both. So let's set up the x. Okay, and if we set up the x and we follow the rules up here and we label our letters, A is 4, B is -5, F is -3, G is 2, M is -49, and N is 28. So basically you follow the pattern up here, label all your numbers, and now we're going to plug into this. So we need M is -49, B is -5, N is 28, and G is 2. And on the bottom we have the C, which is listed up here. It is A, which is 4, B is -5, F is -3, and G is 2. And when we do the Y, the denominator is going to be the same. So we use that bottom on the both. So now we solve this. Okay, if you remember how to solve the matrix, you do cross multiply. We're solving a determinant of 2 by 2. And we do that, we get -98 minus, and we multiply this way, is -140. If you simplify the numerator, it's going to give you 42. The denominator, same thing. 4 times 2 is 8, minus -3 times -5 is +15. So we get -7, which gives us -6. So then for the y, if you look up here, the y is A, which is 4, M, which is -49, F, which is -3, and N, which is 28. The bottom is the same, so it's -7. So then we do our products here. We get 112 minus, going this way, is 147. This whole thing's over -7. So we get -35 over -7, which is +5. So the answer is -6, +5. And you can check that by plugging into the equations and seeing if it works. So Cramer's rule is a review from last week. That's the process. Use the formula. You don't need to memorize that. Obviously, it's in front of you. Okay, there will not be a test on this. So now you're going to do this one on your own. So I'm not going to do this one. You're going to use Cramer's rule and do that one. And then you will have a worksheet to go with this, which you'll practice more. So then what happens if we have 3 variables? So Cramer's rule with 3 variables is a little different. So let's look at the first one here. And then we're going to look at 2 of them, and then you can try one on your own. So the first thing is I want to set this up so I have my x, y's, and z's. So on the top one, I'm missing the 0x. I'm missing the x term. The next one has all of them. And the bottom one, I have 1x. I have a 0y minus a 4z. Okay, so just so we can make sure we see all our variables. So to do this, we're going to use, for the values, the first thing we're going to do is do a matrix that is just the coefficients on the left. So we're going to do 0, 1, 4, 2, -2, 1, and then 1, 0, -4. That is going to be the denominator. Okay, so we're going to do that out. We're going to solve that. That's the denominator. So I'm going to use diagonals to do this. I think that most of us, if we kind of compare that to the determinant rule we learned yesterday, I think we'll do diagonals. So for diagonals, remember we repeat this row here and this row here. So 0, 2, 1, 1, -2, 0, and then we multiply on our diagonals. So 0 times anything is 0. 1 times 1 times 1 is 1. 4 times 2 times 0 is again 0. So this is going to be 1. And we go this diagonal. 1 times -2 times 4 is -8. And going up here, 0 is going to stay 0. And then going up here, we've got -4 times 2 is -8 plus 1, or times 1 is -8. So then we have -16. So we have 1 minus a -16 or 17. Okay, so that is the denominator. Alright, so now we're going to do the numerator. So to do the numerator to find x, to find x, what we do, the pattern for finding x is we take the x coefficients and we replace them with the answers. So -1, -18, and 7 were the answers. -1, -18 is 7, so they replace the x values. And then we plug in our y values, which is 1, -2, and and 0. And then we plug in our z's, which are 4, 1, and -4. And then again, the denominator is 17. So then we do our diagonals. So we have our first set repeated, our second set repeated, and we have -1, -18, and 7. And then we have 1, -2, and 0. When we multiply on our diagonals, we get 2 times -4 is -8. And then 1 times 1 times 7 is 7. And then this one's going to be 0 because there's a 0 in it. So we get -1. Now we go the other way. 7 times -2 times 4 would be 28 times -2, -56. And this row has a 0, so this is going to be 0. And then 4 times 18 is 72. And it's positive 72. And 72 minus 56 is 18. No, 16, sorry. So we have -1 minus 16, which is -17, divided by the 17, which is the denominator. So x is -1. So we found x. On this particular problem, once we know x, we can start substituting back in, because if you look at the bottom equation, x and z are the only variables. So we have x is -1 minus 4 times z equals 7. So we move the 1, negative 4z equals 8. And so z is negative 2. So once you get to a point where you can substitute back in, you do not have to use the rules anymore. And then we're going to go to the first equation, which is y plus 4 times z, so 4 times negative 2 equals negative 1. Y minus 8 equals negative 1. Y equals 7. And once we have all our answers, we list them: negative 1, 7, negative 2, and that's the answer. Okay, so we're going to do another one together. But the rule for Cramer's rule to find systems of 3 is you take the coefficients of the variable side and you do your determinant, and that's the denominator. For finding x, you're going to replace the x values with the answers and then do your determinant with diagonal rule. If you wanted to find y, you would replace the y values with the answers. If you want to find z, you'll replace the z. So we'll see that when we do the next problem. So B, we've got solve the system using Cramer's rule. So let's plug in our numbers. We have 2, 1, negative 1. And then we have negative 1, 2, 1. And then 1, 1, 2. So that is our value to find the denominator. So we use just the coefficients to do the denominator. So let's solve this. We're going to use diagonals. So let's get our first set over here. It's 2, negative 1, 1. And then our second set, 1, 2, 1. And then we do our diagonal. So 2 times 2 times 2 is 8. 1 times 1 times 1 is 1. And negative 1 times negative 1 times 1 is 1. And we get 10 on the bottom. And now we're going to do the same thing going this way. 1 times 2 times negative 1 is negative 2. 1 times 2 is 2. And then 2 times negative 1 times 1 is negative 2. If we put those together, we get negative 2. So we have 10 minus negative 2, which is 12. So that is our denominator for the problems. Alright, so now we need to find our numerators for each value. So we'll start with x. So to do x, again, all the x values get replaced with the answer. So the first x is negative 2, the second would be negative 0.5, and the third is 3.5. The y values, which were 1, 2, 1, stay the same. The z values, negative 1, 1, and 2, stay the same. And then we again use our diagonal, so we repeat the negative 2, the negative 0.5, and the 3.5, and then the 1, 2, 1. Okay, so those are our diagonals. And now we're going to solve this. And negative 2 times 2 times 2 is negative 8. 1 times 1 times 3.5 is 3.5. And the negative 1 times negative 0.5 times 1 would be positive 0.5. And when we add those together, negative 8 plus 4 is negative 4. Now we're on this diagonal. 3.5 times 2 is 7 times negative 1 is negative 7. 1 times negative 2 is negative 2. And then 2 times negative a half is negative 1 times 1 is negative 1. And if we add those together, negative 7 plus negative 2 is negative 9, so we get negative 10. So we have negative 4 minus a negative 10, which makes 6. And then our denominator, again, is 12, because this is the denominator for the whole problem. So we have 6 over 12, or 1/2. So we found x. So now we're going to do y. So to find y, we start off with our determinant, and we keep the x values as they are. We replace the y values with the answers, which were negative 2, negative 0.5, and 3.5. And we keep the z values as they were. And then we do our diagonal rule. So we repeat the first two rows, negative 2, negative 0.5, 3.5. Okay, so those are our repeating our 2 rows, or columns, sorry. And then we do our diagonals. So this is 2 times negative a half is negative 1 times 2 is negative 2. Negative 2 times 1 is negative 2. And negative 1 times 3.5 would be positive 3.5. And if we put those together, we get negative 0.5. And then we're going to go up the other way. So 1 times negative a half times negative 1 is positive a half. 3.5 times 2 is 7. And then 2 times negative 1 is negative 2 times negative 2 is 4. And if we add those together, we get 11.5. So we have negative 0.5 minus 11.5, which gives me negative 12. Again, the denominator is going to be 12 because it stays the same the whole time, and y is negative 1. And then to do z, again, at some point you can substitute these values back in if you don't want to do this whole process, but just so you can see how it works. So if you don't want to do the whole process, once you have x and y, you can plug them back in. But to do z, we're going to keep the x as it was, 2, negative 1, 1. The y is still 1, 2, 1. But now we replace the z values with the answer negative 2, negative 0.5, and 3.5. And then we're going to repeat our first 2 columns. And then we're going to do our diagonals. So let me just get that so we can see there's the repeated columns. And now we do our diagonals. 2 times 3.5 is 14. 1 times negative a half times 1 is negative a half. And negative 2 times 1 is positive 2. And if we add those together, 14, 13, 15.5. Okay, now we're going this way. 1 times negative 2 times 2 is negative 4. 2 times negative 1/2 is negative 1. And then 3.5 times negative 1 is negative 3.5. And this would be negative 5, negative 8.5. So we take 15.5 minus a negative 8.5, and we get, that's going to add to 24. So again, the denominator is always 12 from the first step, so the answer is 2. So our answer is 1/2, negative 1, 2. And again, you can plug these into the original equations to check them. So that is the process you use to find systems of 3 using Cramer's rule. So you're going to try that with C. Let me see. I have the answer for C, so that way you know what you're looking for. The answer for C should come out to be 3, negative 5, and 2. So this is X, Y, and Z. So I want you to do that out and show me that you got those answers. There is a worksheet that goes with this that I'm going to put all the answers without any of the work so that you can then do the work and get the answers, which I think might help you a little bit. So for Friday, you're going to have to do this set of notes and whatever we skipped, and then the worksheet. And both of them, again, I'm going to give you the answers for the worksheet, just like I gave you this answer for what you should be getting. I'll put it right at the problems on the worksheet, and that way you can know what you should get. And so work the problems carefully and double check if you're not getting those answers, and then submit the work of how you got to those answers by Friday at midnight.